to 6.2, and what the new concept for this section is we're going to deal with distributions that aren't standard normal, they're simply normal. So we can do a little bit of adjusting and make them fit into our standard normal curve. So that's where we're going. So we're going to talk about standardizing scores, and we talked about that in chapter, what was it, 3? We talked about that a little bit. So remember, our z-score is r-score minus the mu divided by the standard deviation. And we round z-scores to do decimal places because of table A2. And these are also called standardized scores or standard scores. Now, what we do is we know we can take a non-standard normal distribution, and by using z-scores we change it to a standard normal distribution. So we have those tables, and we have our StatCrunch application, and it can be used with any normal distribution. So let's talk about where can we use this? Well, we can use this, and this is similar to one of the exam questions. We can take people from different distributions and we can actually compare them. So we've got two students. We've got Eleanor, who scores 680 on the SAT Math, and it's a normal distribution with a mean of 516 and a standard deviation of 114. So Eleanor scored above the mean. Well, Gerald scored 27 on the ACT Math, and it is normal with a mean of 20.6 and a standard deviation of 5. Well, Gerald also scored higher than the mean. Who scored better? How can we compare them? Well, we can compare them by putting them on the same scale. And to put them on the same scale, what we're going to do is we're going to standardize each score, and then we're going to compare how many standard deviation units they are from the mean. So let's standardize Eleanor. So there's Eleanor's score minus the mean divided by the standard deviation. And so Eleanor's standard score is 1.44. Gerald scored 27. The mean of the ACT was 20.6 and the standard deviation was 5. Gerald scored 1.28 standard deviations above the mean. So whose score is farther from the mean? I think you can see that Eleanor's score is farther from the mean. And this is how it would look when we would compare it on our standard normal curve. Eleanor's z-score would be at 1.44. Gerald's is just a little bit closer to the middle at 1.28. So again, Eleanor scored higher than Gerald. Now let's look at this example, and what proportion of men are taller than the 72-inch height requirement for shower heads? Okay, 72 inches is 6 feet. We know that the heights of men in the United States are normally distributed with a mean of 68.6 and a standard deviation of 2.8. Find the percent of men who are taller than the shower head at 72 inches. So how are we going to find the proportion? Well, the first good idea is to draw a picture. And we know the mean is 68 inches and the standard deviation is 2.8 inches. So we're looking at how far is 72 inches above our mean, but we're looking for it in standard deviation units. And you kind of see the answer here, but since we're looking for men who are taller, we are looking for the area to the right. So what we're going to do is we need to convert our shower head height to a z-score. So we take our score minus the mean divided by the standard deviation, and that comes out to be 1.21. Now what does that mean? That's 1.21 standard deviation units above the mean. So when we talk about z-scores, we also talk about the z-score is the same as this is how many standard deviation units when it's positive above the mean or when it's negative below the mean. Okay, so what we're going to do next is we're going to find that area, and they're going to tell us that the answer is 0.1123. So let's pause here. I want to pull in StatCrunch so we see that. So let's pull in StatCrunch, and remember I'm going to go Stat Calculators Normal. Remember, this is the standard normal curve, and remember we wanted to know the area above a z-score of 1.21. And that comes out to be 0.1131, or about 11% is above that. So that's how we would do it with StatCrunch. We can also pull in our table, and we want the positive z-scores. So it was 1.21, so I'm going to find 1.21, but this is the area to the left. So I'm going to have to take 1.1 minus 0.8869, and I get 0.1131, which is, you can see what we found from technology and from using the table. Did we find the same thing with technology? I found 0.1131. Okay, now so you can see how that's going to work. But now let's interpret what we found. So again, when we use the table, we found that 0.8869 is the area to the left, so we had to subtract that from 1 to get our 0.1131 when we use the table. And we need to interpret it, and we want to put it in a sentence. The proportion of men taller than 72 inches is about 11.23%. Or about 11% of the men may find the design of that standard 6-foot high shower head to be unsuitable. Some hints. Don't confuse the z-scores and the areas. I think I said this in the last lecture. Remember, the z-scores are the distance along the horizontal scale, but the areas are the regions under the curves, and that is the proportion. And remember, the z-scores on table A2 are in the left column and across the top, and the areas are in the body of the table. So it's important, I would highly recommend you draw a picture and shade which side of your z-score you're looking for. And the z-score that's below the mean is negative, the z-score that's above the mean is positive. And then the areas are the probability, and they're always positive or 0. They are never, 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 never negative. Okay, so again, how do we find values using table A2? So again, if we want to find a proportion or probability from the body of the table and change it into a, find the z-score and then change it into the raw score, we're just going to use a backwards z-score formula. So all this is our standard z-score formula solved for x using a little bit of algebra. And again, if you're uncomfortable with that algebra, that formula is I guess it isn't. That formula is not in the Chapter 6 formulas in the tables book. So either be a good memorizer or be able to use algebra on the standard z-score formula. And then make sure you are looking at the correct side of the distribution, to the left or to the right, the area to the left or the area to the right. So how do we know what to do? We're going to look, what do we want to find? If we want to find the probability, we're going to use the table or technology. If we use the table, we're going to convert it to a z-score, and then we're going to look it up in the table and find the cumulative area to the left. If we're going to use technology, we'll use the technology. That wasn't a very smart little piece there. If we want to find the value of x from the probability or area, we have to decide what's the area to the left, and then we take it again to the table or to technology. And so if we look at the table, we're going to look up that area in the body of the table. And then we can unstandardize our score to find that x that we're interested in. Again, if we're going to use the technology, we'll go to StatCrunch, Stat, Calculators, Normal. So what we've done is we've discussed how we deal with a non-standard normal distribution, a distribution whose mean is not 0 and whose standard deviation is not 1. We've talked about converting them to a normal distribution, and those are z-scores, and then we can find the probabilities using table A2 and unstandardizing, and then we can also use StatCrunch for that.